Hey guys, welcome to Funny Studies. I'm Abrume and today's topic is computer languages and the number systems. So here in our first page we have a few computer languages. The C++, Python, HTML and small basic. No, this is not HTML. It is Python but in uh, in VS Code. Hardware and software. Hardware. Hardware comprises of the physical components that make up a computer system. In other words, you can touch and feel the hardware of the computer. Some examples of hardware are input devices, keyboard, mouse, joystick, devices, printer and monitor, storage devices, hard disk, CD, DVD, pen drive. So the the computer which I'm using to make all of this and present it and record it is the hardware. But the recording and whatever here is the text that is the software. Software is a set of computer programs that provide instructions to the hardware on what to do and how to do it. It is needed for the operating of a computer. A program is a set of instructions that perform a particular task. There are two types of software: system software, application software. So there are two types of software: sys- system software and application software. So whatever is the hardware, how does it work? It works with the instructions given by the software. Stages of program execution. Preprocessing. In this stage, a preprocessor processes the source code and prepares it for compilation. Compilation. The preprocessed source code is passed on the compiler. The compiler compiles and checks for errors and generates the object code. So, in the before uh, in the previous classes, we have learned what is a compiler and what is the interpreter. Compiler, uh, it is like when we are talking with someone who is not, who doesn't talk in the language we understand, and we need some other person to understand what that person is talking and what we are conveying to them. So it is like that. And the middle person who understands both the languages, it is the compiler. It reads the total program and then checks for the errors. Or after the person says, he listens to what all is there and then conveys it to me. An interpreter, it is like the person he says one line and the interpreter he says the one line which in which language I understand, and then whatever I say one line by line he conveys it to the person. Linking. The linker converts the object file generated by the compiler into a single executable program. Loading. The program is then loaded onto the primary memory of the computer system where it gets executed by the processor. So this is the stages of the program execution. Next, the computer languages. Here, as we saw, this all languages are there. But even if there are languages, the computer takes whatever is there as uh, numbers and few specific alphabets. So these are known as the number systems. In that we have decimal number system. Decimal number system is what we use most commonly. It is composed of 10 numericals, 0, 1 and till 9. Binary number system. So we may have here this most frequently when we type of character on the keyboard. For example, here it is there. I want to change it. I'll add 10, 11, 12, etc. But it saves this in the forms of zeros and ones. Even the A, B, C, all of these are also written in the 0 and 1. Octal number, no, these are called binary numbers or bits. Octal number system. The octal number system has a base 8 and it has 8 digits 0 to 7. Hexadecimal system. It has 16 as the base number. It has 10 numeric digits 0 to 9 and 6 alpha digits where A stands for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. Conversion of numeral systems. The steps to convert the number from binary, octal, or hexadecimal number systems into the decimal system are: find the positional value of each digit. Multiply the digit with the positional value. Sum up the products calculated in the step 2. The total is the equivalent value in the decimal number system. So I think none of you understood what is there here. I am going to explain it in some time. A decimal number can be an integer or a mixed number with an integer part and a fractional part. Therefore, there are two processes for converting a decimal number into another other number system. One for the integer part and other for the fractional one. So here I'm just going to take the integer part because the fractional part it is some kind of confusing. Conversion of binary to decimal number system. A binary number can be converted into its equivalent decimal number by adding up the product of each digit 0 or 1 and its positional value as shown below. So here we have our number. So here we have our number. Only till here. The 2 is not counted. It is just merely a number. Here, here first 1, which stands for 2 raised to the power of 3. Because there are two numbers, 0 and 1. So we are raising anything, any number as a power of 2. So first, 1, this is 1 raised to the power of 0, 1 raised to, uh, no, no, no. 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3. So 1 into 2 raised to the power of 3 plus 1 into 2 raised to the power of 2 plus 0 into 2 raised to the power of 1 plus 1 into 2 raised to the power of 0. So we completed the whole number part. Now the decimal point, which is 0.001. So what do we do here? Now we will go to the negative powers, which is -1, -2, -3, and -4. So Then we totally get 8 plus 4 plus 0 plus 1 plus 0.5 plus 0 plus 0 plus 0.0625. Now we add up all of these. Then we get 13.5625. So this is the conversion of binary number system into decimal number system. So for example, we will take the second example also. 1 raised to the power of 1 into 2 raised to the power of 3, 0 into 2 raised to the power of 2, very good. So 1.001 plus 0 1. So here we get the answer as 8 plus 0 plus 2 plus 1 plus 0 plus 0.25. So when we add up, we get, what do we get? We get 11.25. Next, conversion of decimal number into binary number system. So here we do it in some different kind of way. So integer is 45 because binary is 2, we will divide it with 2. Then we get 22 and remainder is 1. And then we again divide it with 2. We get 11. Remainder is 0. Then 2, 5, 1, 2, 2, 1, 2, 1, 0. And then when we cannot divide 2 with 1, so we get 0 as the answer and we take the remainder as 1. Now from the bottom part we go to the top part, which is 101101. And so the number 45 stands for 101101, and the bottom number we just won't consider it. And we completed our chapter. Thank you.